Hey guys, Mr. Wilson here. Today we're going to look at CPCTC notes. At the end of this video, you should be able to explain when to use CPCTC in proofs, and you should be able to use CPCTC to complete proofs. All right, let's recall. How many congruent parts do we need to prove that triangles are congruent? On the proofs we've talked about, we need 3. Okay, how many parts are congruent in congruent triangles? Remember when we first talked about congruent figures, we said there's 6 parts. All 3 sides, all 3 angles. So therefore, if we can prove that 2 triangles are congruent with only 3 parts, and there are a total of 6 parts congruent, then that means that the remaining 3 parts are also congruent by the definition of congruent triangles, saying that all 6 parts have to be congruent. See? So this idea, number 3, is CPCTC. That stands for corresponding parts of congruent triangles are congruent. Okay, so CPCTC says if 2 triangles are congruent, then all of their corresponding sides, or all their corresponding parts, are also congruent. So here in this example, giving us this thing, it says prove that JK is congruent to NO. So notice what we're trying to prove. How's this different than what we've done so far? Is that we're proving parts congruent. Okay, instead of proving whole triangles congruent, we're just proving parts congruent. Okay, so but before we prove parts congruent, what we have to do is we have to first say these 2 triangles are congruent. So why is triangle KLJ congruent to triangle OMN? Well, as we look, KLJ 1/2, OMN 1/2. It's because of side angle side. They have the marked side, the included angle, other marked side. So since the triangles are congruent, aren't all the pieces of the triangles also congruent? Yes. And so then we can prove that JK is congruent to NO because of CPCTC. Okay, here's the big idea, very important to remember. CPCTC is only used after you prove that 2 triangles are congruent, because CPCTC refers to the fact that the triangles are congruent. So until you say, hey, the triangles are congruent, you can't use it. All right, let's go through an example, fill in the blank proof. In this proof, they ask us to prove that AC is congruent to ED. Okay, and so they've given us AB is congruent to BE, they've given us angle D is congruent to angle C. Okay, and that's probably where we're going to start. AB is congruent to ED, or EB, that's given. The other given information is that angle D, or angle C, is congruent to angle D. Again, given. And now just going through with their help, the reason here is that vertical angles are congruent. So our vertical angles that we see in this proof are here. And so we'd like to name those correctly. Angle ABC is congruent to angle EVD. Okay, and that's because the vertical angle is 0. Then number 4, it says triangle CAB is congruent to triangle DEB. Good, it looks good. And that is going to give us angle, angle, side. Angle, angle, side. Notice the side is not an included side, and so it's not angle, side, angle. And so now that we've proven that these triangles are congruent to each other, now we can say, well, their corresponding parts must then be congruent as well. So AC is congruent to ED. And you'll see that AC is here, ED is here. Our congruent statement also shows that. So AC is congruent to ED because of CPCTC. Corresponding parts of congruent triangles are congruent. And there's our proof. Let's go through another proof. Here, it says prove that angle M is congruent to angle R. Okay, and so they gave us some information here. Like I said, a strategy that you can use is just going through, marking out what you have, and then kind of planning your strategy before you write anything. We'll do that this time. Okay, so I see that OE is congruent to OE because of reflexive property. I already was given these 2 sides. So now I should see that these two triangles are congruent to each other because of side, side, side. And now that I know that those are congruent to each other, then M and R will be congruent because of corresponding parts of congruent triangles are congruent. So kind of have a plan in place, didn't have to do a whole lot of extra work. And so we'll start with just the givens. That MO is congruent to RE, and that's given. From there, we can say that ME is congruent to RO, again, given. Okay, and then the thing we added to it, and two things that are equal to each other, so kind of mark those off. We're looking for 3 checks to prove 2 triangles are congruent. The thing we put together is that OE must be congruent to EO. And you could say OE twice if you'd like. And this isn't given. We had to come up with that. It's the reflexive property. But again, we got to say the two things were congruent to each other. So now we have enough information to prove that 2 triangles are congruent. And so we can say that triangle, and I'll find my pattern, MOE, let's do that, 1 to 3. MOE, and then I'll do the same thing, is congruent to triangle 1 to 3, REO. Okay. And that's by side, side, side. Okay, and now that I've proven that these 2 triangles are congruent, I can say that angle M is congruent to angle R. And then I should be able to see that in my core congruent statement that they are in the corresponding parts and there are places, and they are. And that is because corresponding parts of congruent triangles are congruent. CPCTC. All right. So a little bit of tough proofs here. Let's see how we use it here. So they ask us to prove that ML is parallel to JK. Okay. So as we start, JM is congruent to LK, that's given. JK is congruent to LM, that's given and already marked for us. Then they say that MK is congruent to KM, that's reflexive. And I know it's a fill in the blank proof, but I'm still going to mark it for myself because that helps me to understand which reasoning I'm using to say the 2 triangles are congruent once we get there, which we are there now because we've now used 3 marks, 3 congruent things. And so that we can say these 2 triangles are congruent to each other because of side, side, side postulate. And so now we use the side, side, side postulate. And so looking at the next step, it says JKM, this angle, is congruent to LMK, which is this angle. And we know that because of CPCTC. Okay, so this is where we had been stopping, but notice that it doesn't ask us to prove that those 2 angles are congruent. It asks us to prove that the lines are parallel. And hopefully when you're like, wait, prove lines are parallel, where have I heard this before? This is on our property of parallel lines chapter, okay? And we could prove that with either congruent corresponding angles or congruent alternate interior angles, because with congruent pairs of those angles, that was proof enough that our lines are parallel. And so you see here that we have these 2 angles here are alternate interior angles. And since they're congruent to each other, we can use the converse of alternate interior angles theorem, which states that if alternate interior angles are congruent, then the lines are parallel. Okay, and so there we have it. Okay, so notice, does CPCTC always come as the last step in a proof? No, not always. Does CPCTC directly prove that lines are parallel? No, it did not directly prove. It only, we were able to use CPCTC to say that the lines are the alternate interior angles were congruent, which directly proved it. Okay. All right, last one. It says to prove a segment is an angle bisector. We're proving the segment's angle bisector. Here we go. It says given P is the midpoint of IO, and it wants us to prove that PS bisects ISO. So remember what bisects ISO means. Bisects means cuts in half. So it's basically saying, in a way, hey, prove that angle ISP is congruent to angle OSP. Okay, because once we do that, we can say that that means that SP must bisect it, or PS must bisect it. So our given, I'm going to start with that just so I can get it out of the way. I'm going to go through and do our proofs. So P is the midpoint of IO. I already have this marked. Since P is the midpoint, I know that means that these two must be congruent to each other. Okay, because that's what midpoints do. SP is congruent to itself because of the reflexive property, right? And then hopefully my congruent statement lines up that these are corresponding parts, and then it means they must be equal, and then I can say it bisects. All right, so there's our plan. So as I go through looking at these markings and our givens, P is the midpoint of IO, and that's given. Okay, from there, I don't want to continue on to the next thing. I want to use this to say that something's congruent to something, which I already kind of thought of here. IP should be congruent to OP, because that's what midpoints do. But remember, we're not going to write because that's what midpoints do. We're going to say definition of midpoint, because by definition, that is what a midpoint does. Okay, just give myself a little mark because I know that I have something equals to something. Number 3, I'm going to use the other given that they gave us. IS is congruent to OS. And that was given information. We didn't have to work for that. They already told us at the beginning. But we got to say something's congruent to something else. And then PS is congruent to PS. And that's the reflexive property. Okay, and so 5. Now that we've used 3 things that are congruent to each other, we can say, hey, these 2 triangles must be congruent to each other. Let's find a congruent statement that works. So I'll say IPS, triangle IPS, is congruent to triangle OPS. Okay. And that's because of side, 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 as my markings indicate. Okay, now that I've used side, 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 I can use CPCTC. And let's see if angle ISP, ISP, OSP, great. Those are corresponding angles. And angle ISP is congruent to angle OSP because corresponding parts of congruent triangles are congruent. And so now I can say that PS bisects angle ISO because those angles are equal. And that must mean that PS splits it. And that's the definition of a bisector. Okay. So there we have it. CPCTC, got to use it a couple different ways, whether it was proving that corresponding parts are congruent or some offshoot of that lines are parallel, or that the angles was bisected. Undo that. Okay. All right, and got a little bit more on the proofs. So hopefully that was helpful. Well, I'll see you.